Hi everyone. In this video, we're going to build a simple interpreter for an assembly language that's outlined in this Code Wars problem. I'm going to assume that you have some basic understanding of the difference between a high-level programming language and assembly, but don't worry if you don't. I'm going to provide some links in the description box. Summary here is that usually you'll have a high-level programming language like Java or PHP or Python, and that code will somehow get transformed into a lower, quote unquote, lower level programming language. What that means is it's a language where typically it's based on sort of these mnemonic codes. You can see an example of it here, right? And these mnemonic operations will map very closely to what is supported in the computer architecture that you're working in, right? So in this sort of virtual computer architecture that's being outlined, we are supporting 4 basic instructions: move, increment, decrement, and jump not 0. And we're going to solve this using Python, and we're going to try to do it using some object-oriented techniques. The last thing that we're going to do is after we complete and pass the assignment, we're going to upload it to GitHub. And you may wonder, what's the value in doing this? Really, it's bookkeeping. You want to have your completed programs somewhere for you to reference, right? Obviously, your computer may crash. You might lose that information. Also, it's good for you to build your CV, and it's a good way for recruiters to see code that you've written in the past, right? So let's jump right into it. Okay, here. So we want to create a simple interpreter of assembler, which will support the following instructions. Move x, y, copies y, either a constant value, like let's say the number 5, or the content of a register, which would be another variable, into register x. Inc x increases the content of register x by 1. Dec x decreases the content of register x by 1. JNZ XY. Jump to an instruction y steps away. Positive means forward, negative means backwards, only if x, which can be a constant or a register, is not 0, right? Register names are alphabetical, letters only. So you can think of like A to Z. Constants are always integers, positive or negative. So, right, so let's take a look here. This is an example program that they provide for us to execute. So they're going to give us this program, and we're going to execute it, and then we're going to have some sort of output that we display on the terminal, right? So they also have a description of what that code does here, right? So move A5 sets the register A to the value of 5. Inc A increases its value by 1. So now it's 6, right? And then 2 decrement operations. So from 6, we subtract 2, right? Now we're at 4. And then here comes the interesting operation, JNZA minus 1, right? So if A, which is 4, is not equal to 0, then go back up, jump 1 instruction backwards, okay? And you're going to keep doing that until A becomes 0 here, we could see. And then finally, we're going to increment A. And the value of A is going to be, once this program has completed, after this last instruction, the value of A is going to be 1, and we're simply going to dump the value of all of our registers out to the terminal. We only have one register, which is A, and its value is 1. Okay, so that's the basic outline of this program. And so let's go to our IDE, which is PyCharm, and let's create a new project, and let's call this ASM interpreter. Okay, ASM standing for assembly interpreter. All right, So we're creating our virtual environment here, and now we're going to create a new Python file, and we're going to call this assembly interpreter. All right. So let's make a class, right? This is different from the first kata. Now we're going to introduce some object-oriented programming. Class assembly interpreter. And let's quickly come in here and define the constructor for our class, right? And here are the member fields that we're going to have. We're going to have something that we refer to, it's a dictionary of what we call our registers, right? And this will be something like, you know, the variable A, the key will be the name of the variable, right? A through Z, and the value will be the value of that register, like 5 or 4 or whatever it is, okay? We're going to have the program counter. That's the current instruction that we're executing, right? So here we could see back in our, right? So if we execute this, if we're here on this line, when we first start our program, the program counter is 0, then we come here, the program counter is 1, then we come here, the program counter is 2, etc. You get the idea, right? So then, and then this is going to be a neat trick that I introduced. So we're going to create a dictionary called instructions, and what we're going to say is that these labels that they've given us for the instructions, we're going to map them to functions. Self._move. This doesn't exist yet, but we're going to write it. Increment, that was another one that they gave us, self._increment. I think I need to put a comma there. Comma, decrement, self._decrement. And finally, J and Z, which is going to map to self._jump not 0. All right, so now we have our constructor that has our supported operations, the program counter, and our registers. Okay, so right, so let's go to the problem. Let's hit train. For you guys, it's going to be train. I've already completed this, so for me, it says train again. And we're going to come here. This is the method that we have to complete. Here are the test cases they're showing us at the bottom, right? So let's first and foremost, not as a class, not as a, let's define this method, but not as a method that's defined on the assembly interpreter, right? This is just sort of a static routine, if you will, outside of the class. And we're going to get a program, and it's going to be sort of a string of operations we need to execute, and then the dumping of the registers here. So how are we going to do that? So the first thing that we want to do is we want to sort of, let's flesh out that skeleton. Let's say return assembly interpreter, and then we're going to create a method called execute the program, right? So execute is going to be responsible for executing the program and then returning a dictionary of the register dump. Okay, so let's go ahead and come here and define execute self and the program. Just say pass for now, right? Yeah, actually, let's say return an empty dictionary for now, because we know at the end of this we're going to have to return a dictionary. All right, and then also let's introduce each and every one of these. Let's introduce each and every one of these functions that we've mapped to these labels, right? So let's go ahead and say, and I've used the convention to mark these as sort of weak private in Python, right? Def_move self x and y, right? Pass def_increment self x, I believe it was. Pass def_decrement self and x, then def underscore jump not 0 self x y. I believe that was the, we're going to quickly look at this here. X, Y, X, X, and X, Y. That's correct. So these are the 4 instructions that we want to support, right? And so how are these going to be, how are we going to execute these? Well, let's come up here, and the basic skeleton of our execute method is going to be to, while we have more instructions in our program, keep processing those instructions and incrementing the program counter. Okay, so let's say while self.program counter is less than the length of the program, then do stuff, and then after you've done stuff, right, whatever that is, we want to say self.program counter plus equals to 1. We want to increment the program counter, and then afterwards we want to invoke the next instruction. So we're going to say self.instructions of the current instruction. We haven't defined what that is yet. And then we want to invoke that somehow, right? I haven't talked about this yet, this virtual invocation yet, but I'm going to stub this out and leave it, leave this blank. Okay, so let's sort of get into that a little bit more. Actually, you know what? I'm going to delete this line. Let's just increment the program counter for now. Yeah, because what's probably better for me to do is to generate the test case and allow you guys to see the program executing live in the test case. Okay, so I'm going to highlight this method, and I'm going to right click, and I'm going to go to test. And PyCharm is going to allow me to generate a new test case that looks like this. And we're going to come over here, and we're going to scrape the first test case that they give us here into this example. And let's make some modifications to this. Let's just say self assert equals, right? And so now it's telling us it doesn't know where this method's coming from, but we can import it, right? And the great thing about this now is let's set a breakpoint here and go back to our test case, highlight the test, and run it. Let's debug it, actually. Let's not run it, let's debug it. Okay, so here we can see we are now inside of the invocation of simple assembler. We're going to construct this, so if we step into this method, it's going to be the constructor that we jump into. And we're going to initialize the registers, the program counter. Let's expand that. The program counter is 0, the registers are 0, great. And now we're going to initialize the supported list of operations. And then we're going to step back out into the function call of simple assembler. And then we're going to step back into the execute method, right? So now here, let's examine the variable called program, right? If we examine the variable called program, we can see that it's just a list of instructions that they've given us. Move A5, increment A, decrement A, decrement A, just as we expect, right? So now we need to parse each one of these lines to discriminate between the instruction and the operands, okay? So that's what we want to do next, okay? So, and then as you can see here, all it's going to do, the program's going to do right now is just going to increment the program counter a bunch of times, right? You can see here in self, program counter is 4, so 5 now, 6, and then it's done. And obviously this test case is going to fail because we're not doing anything yet, okay? So now you guys got to see how the program sort of executing live, the skeleton of the program executing live. So let's go ahead and fill in the remainder of this. So what we want to say is, first let's declare a variable called parsed, and what we're going to say is take the program at the program counter, right, the line of the program counter, and split it. right? And it's going to split it based on the spaces. And the current instruction is just going to be equal to the array that parsed is going to get, the first argument. And the operands, or the arguments, let's call it args, is going to be everything after the first argument, or excuse me, the first element of the parsed array. So what we'll say is parsed, and I'll use this syntax in Python that says start from the item at index 1, which is the second item in the array, and go all the way to the end. That's what happens when you omit the second the second parameter here, right? So if I said 1, 3, if I said like 0:1, it would get the first two items in the array, right? The thing at index 0 all the way to the thing at index 1. But instead I'm going to say just start at the second element and go all the way to the end, right? So now if we were to set a breakpoint in the program and you were curious as to how this works, let's center our screen again here. Sorry about that. So now, right, if you were to look at this, after I execute these statements, look at what parsed is. Parsed is a list with 3 items in it: the instruction and the remaining operands, right? Current instruction, as I mentioned, is the 0th element of that array, and the args are just the rest of the things in the array, A and 5, right? So now, after we have those things, I'm going to stop the program here, and we will invoke self.instructions of the current instruction, right? Remember, instructions is a dictionary, right? So we're just going to do a lookup of the function associated with the program, sort of the label that the program gives us. We're going to invoke it with the args that we want. So let's go. We're going to use this syntax to say star args, right? When I include the parentheses, right, that will invoke when you dereference when you get the value associated with this dictionary, and then it happens to be a function, by putting these parentheses here, you're going to invoke it, and you're going to pass in the args, right, the remainder of the args into that function. Okay? So then what we should see here is, let's set a breakpoint and move and run the program again. Okay, so let's step in, right? Step in, and when we come here, what I expect is that the first instruction in our program is move, right? So we know that this move string in our instructions dictionary was associated with the underscore move function. And I should be invoking that function dynamically. So if I do a step in, what do you know? Here we are, we're now inside of move, and we can sort of interpret move, whatever that's going to be. I haven't defined that yet. And notice the value of x here is a, and the value of y here is 5. So those were successfully passed in. So now the only thing I have to do is to implement these methods. Let's implement the easy methods first. Increment. Increment is very simple. We're just going to say self.registers of x plus equals to 1. Now let's implement decrement. Self.registers of x minus equals to 1. Okay, now we're sort of halfway there. Move. Move is, let's go back to the definition of move real quick. Move says copies y, either a constant value or the content of a register. This is really important, into register x. So in this example, it says move 5, which is a constant, into this register A. But it could have, instead of saying 5, it could have given us the another register. So it could have been something like B, if B were already defined. And let's say that were 3. Then you would want to move the value of B, 3, into the register A. Okay? That, I think, is one of sort of the mental leaps that you have to make when working on this program. Okay? So, how are we going to implement this cleanly? What we'll say is, let's delegate. Let's say self.registers. We know we're going to assign self.registers of x, but it depends on what y is. Is it a register or is it a constant? So let's write a method called self.resolve y, okay, in order to help us answer that question. And let's write this method up here. So let's say def resolve self, and sorry about that, and let's give this name operand. So what we'll say is return self.registers. I'm going to use the question mark colon operator or the ternary operator. You could use an if-else if you'd like, if this isn't clear to you, but what we'll say is return self.registers of operand if and only if operand is in self.registers, right? Otherwise, convert operand into an int. So what this says is, if what you're getting in here is a constant, like the number 5, then 5 is not going to be a key defined in the registers dictionary, right? You always associate the key in the register dictionary should always be a variable, okay? 5 is not a variable. So 5 is a string that's coming in here as a constant, and we'll come into the else clause and convert it to an int, and that's how we will resolve it, right? Otherwise, if it were, let's say it were move x, x, y, and y were a register, we would basically just give it that value in the if statement, right? So we would say return self registers of operand. Okay, we'll see this live if it's still not clear to you. You'll see this happen live. So now we have our resolve method, and this is going to be useful in a couple of scenarios here. So it's also going to be useful here in the jump not 0 instruction. So if we go to the jump not 0 instruction and we say, let's go back to the definition here and see what it says. It says, jumps to an instruction y steps away. If the number's positive, it means go forward. If it's negative, it means go backwards, right? But only if x, a constant or a register, again, just like move, is not 0, right? So if x were 5, right, and y were -1, like in the example, that says, oh, okay, this a is not, this isn't 0, so then go back 1 instruction and right, go back 1 instruction and do it again. Or if it were +1, it would say jump forward 1 instruction. That's what we're doing here. It's basically implementing if logic, okay? So what we'll say is if you resolve the value of x and it's not equal to 0, then self dot program counter plus equal to self dot resolve of y -1. Okay, so all this says is if this guy isn't 0, then modify the program counter based on the value of the current program counter offset with this guy. And this guy could be a register or a constant. That's why we had this nice resolve routine to help us figure that out and not have to re-implement that logic over and over again. Okay? And that's it. This is our complete program. In less than 50 lines of code, we've made our own simple interpreter. You should be able to come over here and run this test case. Hopefully it'll pass. Oops, it doesn't pass. Oh, that's because when we come back here, I don't think I returned the registers. I did not return the registers. So we need to say return. That's the great thing about test cases, self.registers. Let's try it again. Ran, and it passed. Great. So now that I have my complete program, you can take it, and you can take it over here to your kata, and you can paste it, and you can run your test. There's an additional test case here that we didn't include in our test cases. You can do that on your own. And the tests all pass, and then you can hit attempt to submit this to Code Wars and earn your points. Right, so you usually have to do it twice. You do an attempt, right? It says you may take your time to refactor and comment your solution, and then submit it when you're ready. So then you can do a submit, and then you can compare your program to other folks. The last thing that you want to do is you want to come here and you want to go to VCS, and import your code into version control and share it on GitHub. Okay, so I can share my program on GitHub, and once I hit the share button, basically PyCharm's going to do all the heavy lifting. Assuming you already have an account and you've logged into it on PyCharm, then you can just do your my kata. You can add it. Once you've completed that step, once you go back to your GitHub, you can refresh your GitHub repository and make sure that there's mine, Asm interpreter, just committed 12 seconds ago. Okay, so we'll do a lot of these exercises just to keep our programming skills up to date, and learn new programming languages and new paradigms while we are all cooped up thanks to COVID-19. All right, thanks guys. We'll see you next time.